So we've got this question that says a cyclist starts from rest at point A and moves in a straight line with acceleration 0.5 meters per second squared for a distance of 36 meters. The cyclist then travels at constant speed for 25 seconds before slowing down with constant deceleration to come to rest at point B. The distance AB is 210 meters. Question 1 says find the total time that the cyclist takes to travel from A to B. So what I've done here is I've divided the motion of the cyclist into three parts. The green being the accelerating part, the blue, the constant velocity, and the orange being the slowing down. And to work out the total time, I'm going to break it up into these three sections and work out the time and or the distance traveled for each of these sections, and then take the sum and get the total. So for the green part, for the accelerating part, we're going to use equations of motion. So we know the initial velocity is 0, we know the acceleration is 0, 5, and we know the delta x is equal to 36. So we can calculate the time using the formula delta x is equal to vi delta t plus half a delta t squared. 36 is equal to 0 plus half into 0, 5, and then t squared. T is then equal to 12 seconds. Now while we're at it, we might as well calculate the final velocity, because the final velocity for the green section is going to be the velocity for the blue section. So we can use the formula Vf is equal to Vi plus a delta t. Vi is 0, a is 0, 5, and delta t is 12. So that gives us a final velocity of 6 meters per second. Now for the blue section. We already know the time, and that's about it. Now we can calculate the distance that the cyclist traveled using the formula V is equal to delta x divided by delta t, because it is constant velocity. Velocity is 6 because it's the final for the green section. The delta x is what we want, divided by 25. That means delta x is equal to 150 meters. It is important to work this out because we need that value to calculate the time for the orange section, and you'll see why. Because for the orange section, all we have is that it slows down and it stops. So Vf here is going to equal 0. The Vi is going to be 6 because it was traveling at 6 and then slowed down to a stop. And that's about it. That's all we know. But because we worked out the delta x for the blue section, we can actually work out what the stopping distance is. Because we know the total distance is 210, we can calculate the delta x here. The delta x is going to equal 210 minus the distance for the blue section minus the distance for the green section. So the delta x here is going to equal 24 meters. Now using these three quantities, we can calculate the time. So we can use the formula delta x is equal to Vf plus Vi over 2 multiplied by delta t. So 24 is equal to 0 plus 6 over 2 multiplied by delta t. Delta t is therefore equal to 8 seconds. So the total time that this object is going to have traveled for, the cyclist rather. So total time is going to equal the time for the green section, which is 12 seconds, plus the time for the blue section, which is 25 seconds, plus the time for the orange section, which is 8. And that gives us a total time of 45 seconds. The next part of the question says, 24 seconds after the cyclist leaves point A car starts from rest from point A with a constant acceleration of 4 meters per second toward B. It is given that the car overtakes the cyclist while the cyclist is moving with constant speed. Find the time that it takes from when the cyclist starts until the car overtakes her. So I'm going to start by representing this on a line. So the green portion for the cyclist, so the cyclist is accelerating, and we know that this is 36 meters. Then the blue portion, where the cyclist is moving at a constant velocity or constant speed, and the vehicle or the car catches up with the cyclist somewhere on that green section. So I'm going to call the total distance. So the total distance traveled by the car, by the cyclist rather, I'm going to call that x. That means that this portion is going to be x minus 36. And just so that we're clear here, this is the constant speed section. Then let's look at the time. Now remember, we're talking about the cyclist here. So it took the cyclist 12 seconds to get here. And let's say the total time is tx. That means the time it took the cyclist to travel from here to here is going to be tx minus 12. Now we can set up a equation here. We can say that since that blue section is constant speed, we can use a constant speed formula. So the formula is, now remember again, this is for the cyclist. The speed is equal to the distance divided by the time. Now, during the constant speed, the cyclist, as we calculated earlier, was traveling at a speed of 6 meters per second. So 6 is equal to, in that section, the distance traveled before the car overtook or caught up with the cyclist is x minus 36, divided by the time for that constant speed section is tx minus 12. Now let's solve for x. So 6 into tx minus 12 is equal to x minus 36. We can now simplify, and we'll get x is equal to 6tx minus 36. Now let's take a look at what's happening to the car. So the car is starting at an initial velocity of 0. So vi is equal to 0. Its acceleration is given as 4 meters per second squared, and it is traveling for a time. It's going to be the time that the cyclist is traveling, so tx minus 24. And that's because it is traveling for a total time of 24 seconds less because it started late. Now we can set up a formula using one of the equations of motion, and the formula we can use, so delta x is x, and the formula we can use is delta x is equal to vi delta t plus half a delta t squared. Now the car and the cyclist would have traveled the same distance from point A when the car catches up to the cyclist. That's really the important bit to understand there. So x is equal to 0 because vi is 0 plus half into 4 times tx minus 24 all squared. That means x is equal to, now we can simplify a bit, we'll have 2 into tx minus 24 all squared. Now, as we said before, when the car catches up with the cyclist, they would have traveled the same distance. So I can equate this and this. So this and that. And I can solve for time. So let's equate them. So we're simply going to say that x is equal to x. So 2 into tx minus 24 all squared is equal to 6tx minus 36. Now we can simplify and write this in standard form. We'll get 2tx squared minus 102tx plus 1188 is equal to 0. That means tx is going to equal 33 or 18. Now we're going to reject the 18 for the simple reason that at 18 seconds, car hadn't even started. The car only started after 24 seconds. So the answer to the question is after 33 seconds. Now for those of you who prefer graphs, here's how it would look. So I've broken this up into the different motions here, and let's highlight it. So for the cyclist, the green portion is the accelerating portion. So I'm going to highlight this in green. This represents the acceleration of the cyclist. Then the constant velocity is going to be the blue portion. So this portion right here represents the constant velocity of the cyclist. And then let's use this orange color to represent the car. So what I really did here was I solved for the points of intersection of the two graphs. So step one would have been calculate the equation of the straight line, of this blue line, and then calculate the equation for this line, and then solve for the points of intersection. So you'll notice this blue line has an equation of y equals 6x minus 36. And there's it here, 6x minus 36. And this parabola has equation of 2 into x minus 24 all squared. And there we go here, 2 into x minus 24 all squared. And as you can see again, we have 2 points of intersection, one at 33 and one at 18. But the car hadn't been moving at 18 seconds, so we rejected this value. And that's it. Guys, if you stuck around till the end, thanks so much for watching. Don't forget to leave a like, share and subscribe for more. I'll see you in the next one. Bye bye.